Merci, Denise. Hello, troopers. So it's still a great pleasure to be in front of you today. So as Denise said, we are supposed to be two, but one of my colleagues is sick today, so please excuse him. He had tried his best to be back, but unfortunately, sometimes we cannot. So the topic of this talk is to go in a journey inside a new feature of Windows, which is called Smart App Control. And for that, Dr. David Baptiste, I'm French, which explains my wired English accent, I would say. I'm working since 2 years for ETW, which is the host of the conference, and I'm a security researcher over there. I make a couple of conferences, including Troopers, so it's always a great pleasure to be with you today. As we said for Till, cannot be here present today, but very great guy. And also another person works for us on this topic, which is Dominic Phillips. He works for many years in ETW, and it should be mentioned in this work also. So, Smart App Control. With Windows 11, especially the version 22.572, a new security feature has been introduced, first in Windows Preview and then in other operating system version of Windows 11, which is called Smart App Control. And the main idea of this feature, which was new, as announced by Microsoft, is to block what they consider as unsafe application. So more directly, it's just going to focus on what is considered to be safe on your laptop or your machine and remove everything else. Nothing else can be launched except that. But the point, of course, of such a feature is to be able to define what means a safe application. And it's exactly how it's going to work, because from Microsoft documentation, well, some people will say marketing stuff, it's written to be the decision of checking which application is safe or not is based on intelligent, cloud-powered security service, which is not so meaningful from my point of view. So, BSE in Germany asked us to study these features and to document how it works, to make an evaluation of what is real behind the stage. So today we are going to check what is behind the stage of Smart App Control and Windows Defender, because both are really connected. A bit of documentation before, just for announcements. Smart App Control, so it's literally from Microsoft Doc. Smart App Control works alongside your other security software, such as Microsoft Defender or non-Microsoft antivirus tools. Smart App Control is based on a technology which is called WDAC. WDAC stands for Windows Defender Application Control, and the notion of application control is defined also in the documentation like a feature to help to mitigate this type of security threat by restricting the application which are allowed to run on your system or not. And as it's correctly written, application control is a crucial line of defense, okay, which takes inherent advantage over traditional antivirus solutions, so it's not an antivirus solution, which moves away from the trust model, which is based on applications which are assumed to be trustworthy or not. And that's the idea of application control, only to execute the application which are defined to be safe. And as an important note, still from Microsoft documentation, they always recommend you to maintain an antivirus. So for short, Smart App Control is not an antivirus, just based on what we read in the documentation. It's based on WDAC, and it's more or less an involvement of this technology. And WDAC is used, as we say, to block application. A relevant point concerning Smart App Control. This one is only available on Windows 11, and it's active by definition directly out of the box of Windows. So the first time you install Windows, it's there. You can decide, if you want, to switch it off. Say, okay, I don't want Smart App Control, I want to disable it. Fine. But the point is that once you turn these features over, you cannot turn it back. It's once for all. Once you have deactivated it, it's forever. Well, forever. You can always reinstall Windows, but it's a clean reinstall of Windows. This feature is defined by Microsoft so that Smart App Control can only work on the system if the system is considered as safe, which means, with other words, that there is nothing before which has already run on your system. So we can trust the system if it starts from a clean state. Okay. So to do that, Smart App Control has 3 different stages. So at the beginning, when Smart App Control is launched, is what we call the evaluation mode. So literally, you observe what's happened on your system, which application are launched, when do you launch them, is it safe or not, and it makes an evaluation. Will this application be considered as safe if I will be on, or will it be not considered as safe? And it gives you sometimes some feedback just to tell you that maybe you should not use that application. So that it tries to educate yourself to use safe application, or what Microsoft considers as safe application, to be honest, instead of using unsafe one. And then after 20 days in average, but it can be more or less, that stuff is dependent of Microsoft because it's based on feedback from Microsoft. SAC can be switched in 2 different modes. The first one is enforcement mode. So it means that Smart App Control is now active. Now, when you see an application which is launched and considered as unsafe, this application will be blocked, and no discussion. You cannot say, I want this exception. No, no, no. There is no exception in this context. Only untrusted applications are going to be blocked, and all the other applications will be executable. Or, if Smart App Control considers it cannot help you to defend your system, no problem. It's switched off. And in this situation, it does nothing, it observes nothing else, and it's literally not here. But the point is, you cannot turn it back. You cannot say, OK, but maybe I changed my mind, I would like another evaluation. You cannot. It's once for all. If you want to turn it back to evaluation mode, you need to reinstall Windows. Yeah. The interface is very simple, 3 buttons, on, evaluation, off. Of course, you can decide by yourself to turn it on, but it's on your own risk. It's by yourself. You decide you want to do it, you do it. But in this context, if your machine cannot be useful because some applications are blocked, that's for you. OK, that's what is Smart App Control. So Smart App Control just select application which can run or not based on what they call an intelligent cloud-powered security service. Well, cloud analysis, it's just giving samples to the cloud and the cloud answer you yes or not. Just question. If you do not have internet connection, what's happened? In this context, the documentation is very clear. By default, applications are blocked when Smart App Control is not able to make the disclosure to the cloud analysis. So Smart App Control is a feature which really requires hard requirements, which means internet connection, evaluation from the beginning, the evaluation period should be fine so that it turns on, and so on. Well, it's big stuff. There is one exception, which is very meaningful. If one application is signed with a certificate issued by a certificate authority within the trusted root programs, so VeriSign, DuckDuckGo, and so on, so a certificate you can buy from different providers and trusted by Microsoft, in this case, applications are executable. And of course, Microsoft applications are signed, all of them on the system, so your system is safe. So that's how it works. So Smart App Control is nothing else than an automatic and optionless security features. You can deactivate it, but it's forever. That's all. So that's, in a nutshell, what we can have from the documentation. Now, let's make a little journey inside. At the beginning, from explorer.exe, when you execute an application, the application has a long path over the system, and it goes to the kernel, so to create a new process. And in the kernel, there is a notification which is performed to a DLL which is called ci.dll, codeintegrity.dll, to check if your application could be allowed to run on the system or not. In other words, that's literally the home of WDAC features. Then ci.dll checks on Windows policies, which define which application can run or not. Windows policies is just something like, it can be used on command line, of course, but in the end, it's just an XML file which defines which application can do what based on signature, metadata, and so on. Windows policies say yes or no to ci.dll, and then the kernel allows the execution or refuse it. Very simple. As we said on the documentation, WDAC is, Smart App Control is based on WDAC. So it's based on ci.dll. So let's dive in ci.dll. At the beginning, when you have an application which is notified to Smart App Control from kernel point of view, it's going to match this function, ci validate image header. And the first thing it's going to do is to check if your application is going to be analyzed by Smart App Control or not. In this table, I represent all applications which are notified to ci.dll. So application, regular executable file, installer, and so on. Script, they take another path. Drivers and installer, MSI or setup.exe if you prefer. That's what goes in ci.dll, but when we check later what goes really in the analysis process of smart app control, we have a slightly difference. First, all the driver line has disappeared. Well, it makes sense because it's technically kernel mode code signing requirements. So this check is only done in ci.dll, and more exactly, it can be done on the VTL1, the virtual-based security system of Windows where trusted code is executed in a parallel hypervised environment. So that makes sense that we do not need to come back in another system analysis. But the application from Microsoft Sign are also never notified to SAC, probably for optimization purpose. Or also, if you want something done, do it yourself. That's a good way to escape their own security. So we are going to focus on third-party signatures, untrusted third-party signatures, when you sign yourself your application, and unsigned application, and installer software. Okay. Once we have selected which image or which kind of image are concerned by SAC, Smart App Control, SAC, that's a shortcut. Signature check and get edge image. So the goal is to extract from your binary any signatures. And the system is quite simple. First, you have an indicization of signing level. We are always in ci.dll. Validate page hash or validate file hash. We take the hash page of memory per page of memory, or we take the hash per file. Then we select which algorithm we want. Usually it's SHA-256, but for legacy purpose and backward compatibility, you have still SHA-1 in case of. Then you've got the embedded signature and first match. So it's literally extracting all the signature from your binary. One match, we stop, and doesn't match anything. We continue if there is another signature in your binary. We calculate the image hash, and we find a matching hash. And in the end, you have a couple of possibilities, different functions, I will say, but you have something which is usually linked to the notion of catalogs. Catalogs, this is a kind of file on Windows which regroups all the signatures of different binaries, so that your binary doesn't hold the signatures, but it's all in another file. And this verification is performed by a third-party component of Windows, which is a service in user mode. That's the regular process, I will say, of ci.dll. Until now, we are not exactly in smart app control. It's regular WDAG stuff. Then we are going to apply the WDAG policy matching. The first thing that the kernel does is to check the system, a system of cache. In fact, if the application has already been analyzed and nothing has changed from that, no need to remake a verification. Nothing has changed. So it should be the same result every time. So to do that, the system has what we call a kernel extended attribute. So it's a sort of metadata which is added to your file via the file system to know that there is already something which has been analyzed, there is crypto system inside, signature stuff to be accurate. And the goal is to say it has been checked, it could be launched. So that's a cache system, file per file for optimization purpose. If you do not have anything like that, if you do not have a cache system. Oh, by the way, just talking about the cache system, this kind of extended attribute starting by $kernel, it means that's a kernel extended attribute. You can only modify it if you are a driver. Administrator is not enough, so you really need to be the kernel. So if you do not have any cache, we are going to call the function CIP apply SI policy exe. Okay, great. These functions takes many elements. First, a validation context. The validation context literally provides all the data you need concerning your application. The path of your application, the hash, the signature, etc. Everything which concerns what you want to execute. Then you have policy objects. That's the number of policy you have in the system regarding WDAG. And then you have a validation procedure. So linked to every policy, if there is a special treatment for this policy, we can execute a specific callback doing a specific feature for that policy. What is SAC? Technically speaking, it just, after the policy, we have a yes or no, of course. But SAC is only that. One specific procedure, which is called CIP external authorization callback, and a SAC policy which says to the system, use SAC or not. That's what is technically SAC, at least from the kernel point of view. Okay? Let's check what does this callback after all. This callback is not so complex. First, it's check what they call a security attribute token. It's also for optimization purpose and cache system, but it's not so relevant for what we want to see. Then it's going to check if the extension of the file you want to check or you want to use is considered as dangerous. So we have a lot in this list of extensions. Of course, executable is by default included. Makes sense, you started to execute an executable file. And also installer, MSI, are in this list. And then, once they have, the callback has performed this check, is going to do a little bit more. The goal is to make the transition from the kernel to the user mode where the analysis will apply. So as I say, first, file check extension. Then there is a call to a function which is called CI cat db smart locker defender check. We have this notion of smart locker, smart app control. So inside, when we reverse Windows, we have access to symbols in this context. And we have different names, probably the old code names used by the project during the development. So smart locker was one of the code names. Also another one is Nightwash, was another code names used by Microsoft regarding this feature at least. He's going to ask to the rest of the system what to do with the file, manage the answer, and if the answer is positive or negative, put something in the cache file system we mentioned just before. Okay? So we are going to dive in the procedures of smart locker. This one first starts by making a connection, RPC connection. So RPC, remote procedure call, is just a way to make inter-process communication, a very convenient way to execute function in another process, which is used for decades by Microsoft. So the goal is to make an interface which is called key SVC, and that's the UID of this RPC interface, and when we look for in the system which process has that, it's a service which is called cryptcat service. Okay, good. So the first is to make the connection. Then there is a way for synchronization. It checks that the service is there and the RPC connection is correct. And then it tries to call this function. Really, the names are very long. SS, cat, db, smart, locker, defend, check, 2. The 2 is important. Apparently, there was a 1 before. Why not? And once this function has been called, it is going to pass the answer, which means more or less manage the answer, and so on. So all the heavy stuff is performed in this function. And what does this function? Well, it's very simple. It directly makes an RPC call to a function inside this service. So this is how the WDAC makes the transition for smart app control between the kernel and the user mode in Windows. Cryptcat service. Cryptcat service is literally launched at the execution of Windows, at booting time, to be accurate. See Windows System 32 is in svc host.exe, and its code name from argument point of view is crypt service. But it mostly relies on that DLL, cryptcat service, and the name of the service internally registered is this one, cryptcat service. This service, when we reverse it, is quite simple in a way. It's literally there to manage catalog file. You remember the catalog file where all the signatures of all binaries in Windows or drivers are present, so that we know which one is signed and how it's signed. So that service is literally responsible to check all the chain of certificates when a binary is signed on Windows. Makes sense when you think about ci.dll is there to check signatures and policy, actually. So in this RPC interface, you have the old function used usually by these cryptcat services, but you have 4 more functions which are definitively related to smart app control. So it's very interesting to see the mix between a service which was clearly identified before to make interaction, I would say, with only signature and catalog file, and now in between you have smart app control. Okay. You have 2 kinds of functions. The 2 last is about app control block toaster, switch on for smart post. It's more or less to display something to user eyes. So it's GUI interface, not so important. But the 2 most important are this one. Cat DB smart locker defender check 1 and 2. 1 is not written, but it's like that. But in the end, both functions rely on the same function, which is this big function, which always has smart app locker defender check helper. Okay? This function is really responsible to make the transition from the cryptcat service to Windows Defender. So it's just a proxy, if you want, between the catalog services analysis and Windows Defender. WD, sometimes I miss some size in my presentation, so WD is the shortcut I use. To proceed, cryptcat service is going to load a DLL, which is called MP client from .dll. This DLL is the interface that any application can use to interface with Windows Defender. Well, when I say any application, I will say Microsoft application, because it's undocumented stuff. So you are not supposed to use it. He is going to find that DLL based on a registry key, and once the DLL is loaded once for all. The first time it's loaded, you have a specific initialization which is performed by the service, which is called MP Smart Locker Enable, just to enable Smart App Control. Otherwise, it's just shared in memory. Then, you remember you have function 2, function 1, so they are going to follow their path in parallel, but when the function 2 doesn't work, it always tries a legacy function. So invoke MP query trust by handle is going to call MP query file trust by handle, and so on. These functions are responsible to do two things. The first thing is to load the targeted file in memory, because at the beginning the target file is on your disk, and to be analyzed it needs to be put in memory somewhere. So this is a service, cryptcat service, which is going to load it in memory. Interesting, because it's not that service which is going to analyze it. And then it's definitively making the transition with Windows Defender via its RPC interface. The RPC interface of Windows Defender is totally undocumented, but it's very interesting from my point of view. The function which is responsible to do it is this one. I give you the name if for people who are interested to check how it's possible to interface directly with Windows Defender. As any RPC interface, you have a UID, which is provided over there. And the access to this RPC interface is more or less controlled. First, you need to make the interface via mp client.dll. Well, technically, you could try without, but there is some check. So when you call some API, sometimes Windows Defender goes in your memory space and check who is really calling you, to check if the code is using regular stuff or not. Also, there is RPC impersonation. So technically, Windows Defender is full power on the system. And to avoid to do bad things, is going to behave with the same privilege as the calling process, so that it avoids, well, it's trying to reduce privilege escalation. So that's the interface. You have a lot of functions, but some are very interesting. Query status, disable feature. I like disable feature a lot. Demand start scan. You've got demand thread open. You have RPC control. You have quarantine control. You have elevation handle open, signature thread open. You have Spynet. Spynet is used to make report to Microsoft Cloud, to ask the cloud of Microsoft to give you feedback. We have also thread close, production genius checklist, fast memory scan, if you want to make a scan which is faster than the usual memory scan start. And you have literally the remote control over all the features of Windows Defender. You have even the possibility to update the signature the way you like. Everything is there. Check for drag and drop operation. You have also one for IMSI in the list somewhere. Well, you have a lot of stuff over there. Okay? That's the interface of Windows Defender. That's the remote control of Windows Defender. Make a short parenthesis, just trying to explain how works Windows Defender in a very simplified way, because Windows Defender is a big antivirus, big software, and it involves a lot of components. At the beginning, the service is launched from that registry key, HKLM, software, Microsoft, Windows Defender. If the service is not found directly in that registry key, the system tries Microsoft anti-malware. That's the name of Windows Defender back to Windows 8. So for backward compatibility, still present in the code. Then we try to execute the most recent version of Windows Defender. So that's why the path of Windows Defender includes the version number over there. If by default you cannot find the most recent version of Windows, no problem. We take back the last version known to be correctly executed. So that way, Windows Defender has also a mechanism of, I would say, which tries to avoid any mistakes. In case of mistakes, it can always roll back from the beginning. So we start with the executable msmp-engine.exe. It's literally more or less like SVC host, which is the process which is going to host the service of Windows Defender. The name of the engine inside is called Asimov. That's a code name for the analysis engine of Windows Defender. And the first thing it's going to do is going to load the DLL, which is called mpsvc.dll, which is literally the service, which has a service CRT main function. This one is going to check which is the last drop location and if there is any update in the system to use. If not, the service is going to create the regular stuff for service. So it has an on startup procedures, on asynchronous startup procedures. This one is very interesting from my point of view because it creates what we call a thread pool. A thread pool is literally a set of threads which are waiting for works and tasks to do, so that everything is asynchronous. So you can have a module dedicated to, I would say, memory analysis, for instance, which are waiting for tasks to do, and you have another module, I don't know, which is for network analysis, which has another thread pool. And that way, when you ask for something to Windows Defender, it's going to push a task to one thread pool or another thread pool, and everything is performed in parallel in a more or less optimal way. Well, it's quite optimal, actually. You have also a service dispatcher for any service. It's always the same. And then the service main function is going to call init mp service, which is a real initialization of Windows Defender. This is where you can have all the information you like on Windows Defender, everything it does. The capability to make network scanning is there. It's how it's initialized. The capability, how it makes an update of the system, an update of the signatures, how it's going to initialize the scan memory, engine, etc. Everything is there. And in the end, it's going to load the DLL, which is called mpclient.dll. mpclient.dll is the same DLL which is used by the CryptCat service. So it's also used internally by Windows Defender, but more or less for support purpose, to handle thread pool, for instance. It's a good way to do that. Then you have mpengine.dll. So this is exactly the analysis engine of Windows, where all the heavy work from analysis point of view is performed. You have also mpcommu.dll for communication, to communicate with the cloud of Microsoft. You have mpoiv.dll for everything which is linked to Office document. And you have also mprtp, real-time protection. This is the DLL which is in connection to the drivers of Windows Defender, wdfilter.sys from my memory, which is supposed to hold all the system events in real time. And then, when you want to interface with, as a reminder, you always need to have the MP client, which is in connection to mpsvc.dll. That's the architecture of Windows Defender, at least a simplified one. Well, let's come back to the transition between CryptCat service and Smart App Control within Windows Defender. So we have that function, which is called mp-check-mapid-file-trust, which is going to call that numbers in hexadecimal RPC function from Windows Defender. And the function which is targeted is server mp RPC memory scan start. So you see, we have removed the notion of smart, we have removed the notion of locker, we have removed the notion of Defender. Now it's regular scan start. Interesting. The analysis is performed asynchronously, as we have said with thread pool. Something interesting, because all the operations are performed asynchronously, at the end, the client will ask for the analysis needs to have a return. And because it's asynchronous, you need to synchronize to get to know when the answer will be provided. And to do that, Windows Defender uses a global event, which is named with a GUID. That's interesting, in fact, because GUIDs are designed to be unique, not random. So I think, in a way, if we are a bit smart, we could try to make a denial of service. Well, you are attacking yourself. It's not so interesting. But that could be a possibility. Duplicate handle in memory would have been a better approach from my point of view. But that's literally side note. So how works the evaluation? Let's make the journey. We are only going to focus on the main relevant function, and you will see there are a lot. First of all, we are in the service DLL, which is about to create some stuff with C++ programming to create an object which is called a CMP memscan context memory. And we are going to initialize it. And when we are doing the initialization, we are literally doing the analysis. We are switching to MP client. It's just call of function, and there is no mystery in between. It's just a function call to another function call. And we have the submit process. I like this word, provider vista. It gives all the literature and history concerning Windows Defender. In fact, it's just pushing something in a thread pool, but we know this thread pool from the initialization, and we know it's going to be back. So that's still MP clients which manage the thread pool at the beginning just to dequeue the task to do from the thread pool. And then back in MP service. Do action, on action, do scan. We will talk about do scan in a few seconds. And then we have air signal wrapper. Air signal wrapper is a function to communicate asynchronously, again, with MP engine. And we give this special value, R6 scan stream buffer, and in air signal. And then the engine is going to continue to process that signal. Cast signal is the important function, which makes the translation from that value to this function, scan stream buffer. Makes sense because the buffer is in memory. So we are going to scan the file in memory. And then the most important function in all this scanning operation from our point of view, because it does a lot, really a lot, is this function, generate BM spynet report, which is communicating with mpcommu.dll. So literally the CLUD notification to Microsoft. As a side note, I have a couple of minutes, so it's okay. For the record, coming back to this do scan function. This function is a C++ function, so it literally holds a set of methods in the object from where it has been called. And in the set of function, I would like just to focus on VFZ read operation. And inside this one, you have a call to that function, read process memory. What does it mean? It means that when Windows Defenders like to scan a file in memory, it doesn't load it by the file by himself. It's going to act as a debugger. It's literally reading in your memory space of the calling process your file. I think it's maybe for optimization purpose not to reload twice the same file in memory, but actually that's quite odd. That's original, I would say, to act as a debugger for an antivirus, but why not? So it's how it works. So when you want to submit a file to Windows Defender, don't send him the path of the file, just load it in memory, call the right function, and Windows Defender will take it by himself. Okay, that was the parenthesis. Let's come back to the communication because it's very interesting for us. mpcommu is going to generate a spynet report. Spynet report is the name of the kind of report which are used internally by Windows Defender to make submission literally to the rest of the cloud of Microsoft. This is the name of the function which is doing it. It's very, very long, but submit report is the most important stuff. And this request is made to that domain, wdcp.microsoft.com. That's that IP from us in Germany. The full URL is given there, boon, submit report. You have the user agent, MP communication. You have the version of the operating system, the platform version, and the online version of Windows Defender. That's all you need to provide to make the communication with the server. And you accept it, very fine. The security is present. There is a way to prevent man in the middle. It's just regular certificate pinning inside this function, check certificate Microsoft root, based on win HTTP query option and cert verify certificate chain policy. So it's correctly done. So you cannot too easily intercept the communication, if you are not already on the machine at least. The content of the spynet request is packed. So it means it's not easily readable. Well, with reverse engineering, it becomes readable. So we have the possibility to extract all the information from a spynet report, and we have very interesting information. When you make a smart app control request, at least Windows Defender does it for you, it provides the machine information, engine report GUID, machine and product GUID, OS platform, a lot of information about your current machine. Also, in Windows Defender information, it provides all the Defender's version numbers, signature, engine, database of signatures, quarantine, and so on. Everything is provided. Windows Defender configuration value, how the services start, tamper protection, state. All the configuration and policy for Windows Defender is sent automatically and every time. Trust mode state, if there is different sub-mode in Windows Defender, which is included or not. So literally, every time you disclose something for malware analysis, Microsoft knows exactly how is configured your Windows Defender. You have a signature request. From my point of view, it's just to track the request we are going to send. But it's very interesting to have an history so that it gives information to the previous submission you could have done by yourself. And of course, you have the file content query. So you have the real path, the hash of that path, the file name, SHA-1, SHA-256, MD5 also, why not, CRC, the file size, PE attributes, file type settings, imp hash, name, original name, version of the software. That's unknown hash for us. It's hash more or less of some section, I would say. I like this one, mod w ref URL. It's when you download the file, Microsoft keeps tracks of from which website it has been downloaded. Or if you have extracted the file to a zip archive, it keeps tracks to the archive where the file is from. Kind, isn't it? And then you have the mark of the web and so on. This is exactly the NTFS attribute, which is used in download directory when you download something to Windows and you execute from download directory. That's exactly the same stuff. Same logic, at least. Mostly this is metadata concerning the file. At the best of our knowledge, there's not directly the content of the file. The only stuff from the content of the file is PE attributes, but it's more from compilation point of view interesting than what really your executable does. So you don't have any disclosure like that. If you want to have an overview of how it looks like after reverse engineering and parsing the content, so it's literally a lot of values, I would say. And you can see the path, the name of the application, and so on. And you have also the name of the zip application, which is the zip archive where we have extracted the software which have been used for test purpose. So everything is there. Well, not everything, but at least from file query, you have more or less everything. So the answer from Microsoft. So we send information to Microsoft. Microsoft answers us. Nice. Once the answer is received, this one is parsed by this very long name function. The goal of this function is to extract all the information provided by Microsoft to know what to do with that executable. Because in the end, Smart App Control is going to say that this app is trusted by Microsoft. You can execute it. This app is untrusted by Microsoft. It's blocked. So it's exactly the stuff which is going to do. So a feedback about the analyzed file. And also a potential information, so it's not always present, but it can be present, about the current mode in which Smart App Control is running. So you remember at the beginning, Smart App Control has 3 states. Evaluation, where the Smart App Control observes the system. Enforcement, where Smart App Control really blocked or not application, and off. So the transition, the way to switch from one state to another state, is driven remotely by Microsoft from every answer it provides to you. So that's Microsoft which can decide yes or no you are going to do it or not. So we do not have the logic because the logic of this choice is on server side. And for obvious reason, we don't have access to the server where this algorithm of choice is performed. But it's driven remotely. The answer is personalized for Smart App Control. Despite the fact that SpyNet is used as a very generic stuff for all the application and everything where my Windows Defender needs to disclose something to Microsoft Cloud Analysis, Smart App Control has specific attributes so that the answer is personalized for Smart App Control Analysis. So that's how it works, at least from the feedback. If you really want to have a deep look on the feedback, so it's still packed, so we need to unpack it. And then you have many blobs in the answer. One blob is a signature, so that the answer is correctly signed, and we know that it's going from Microsoft. You see, you have the man in the middle protection, and also a signature of the answer. The goal is always to increase the security. So the message is signed. The message contains information relative to the original request, so that we have a track down. We know from which request we have the answer, because everything is asynchronous. In practice, we have also 3 interesting blobs, which all start by a magic number, which are provided over there, and which gives the decision to do. If SAC is in enforcement mode, so it means he is going to block or not, or he is going to allow your application or block your application. If SAC is in evaluation mode, you have just a notification, sort of WNF toast. Sometimes when you receive a mail, you have a pop-up which comes from the bottom right of your screen in Windows. That's exactly the same kind of notification. And it can change the status case of SAC, enforce mode on off. That's how it works. The changing procedures is more, we can describe it for short, very for short. So that Microsoft Defender antivirus, which receives the information, is going to disclose it with ci.dll, which has a specific procedure for that. The first is to change the kernel configuration, because it's impact also ci.dll, which doesn't need anymore to notify Cryptcat services. We are going to update policy in SAC and WDAC to stop it correctly. And then we have two kind of procedures. On the one side, we have a RPC toast notification, so we are going to retalk with RipCap SVC. And if you remember, in the RPC interface of RipCap service, you have the regular RipCap service features for catalog file, but you have also four functions for smart app control. The two first are for notification analysis, and the two last are for display control, GUI. That's exactly these two functions which are going to be called here, to inform you that something had changed concerning SAC, or the application would have been blocked if SAC would have been in enforcement mode. And the other one doesn't use anymore RPC, so the notification is performed via WNF notification, which is another kind of inter-process communication from kernel mode to user mode, and user mode to user mode also, which seeks to inform to Microsoft Defender antivirus that, okay, I've correctly taken it into account, the fact that SAC is now in that mode or in the other mode. Now your turn, you can switch your configuration also. So it's not Microsoft Defender which changed it before, it's really ci.dll which changed before, and then it informs Microsoft Windows Defender antivirus, so Windows Defender, to do it by himself. So that's sort of ping pong. Okay, so we have seen how works Smart App Control. For those we are interested by, we have the possibility also to have a tracking of what happens in Windows Defender, a sort of printf, but for Windows Defender, to check what are the logs inside. Windows Defender has two kinds of log internally. The first one is the regular log txt file. It's very old school, but it's very convenient. By default, they are generated all in the same place. C, program data, Microsoft, Windows Defender, support, prefix log file, and the date. The date describes the date and time where the file has been generated, and the prefix can be mplog, mp something, and so on, depending on the different features. I really advise you to check it because it's very interesting. For those who are interested by, it's initialized by this function, which is called at the end of init mp service function. You remember at the end of the initialization of Windows Defender. And also, Windows Defender, in not all of these functions, but in a lot of its functions, has ETW or WPP tracing within the code. And it's a very gold mine if you want to track what this function does without having to reverse engineering everything. But there is a little problem concerning it. First of all, regarding Smart App Control, we do not have a specific ETW provider. So it means that we need to deal with all the Windows Defender stuff, which is a very interesting clue, because it says, without saying it, that Smart App Control is just a feature which is a Lego of different existing components. It's not something by itself. You see? When I said in the kernel that it's only about the notification and the change in a policy and a specific procedure callback which is provided for that policy, I mean it. That's SAC. What is really it? Smart App Control. But in Windows Defender, it doesn't make a huge difference. It's not big enough to have their own ETW provider. And in ETW provider, talking about it, Windows Defender uses it for getting information and providing information. So providing information, as I said, is the printf of the process. So it's very cool. We have literally line by line what does it do. And for information retrieving, so that ETW is also used by the kernel to say that this function has been called, this stuff has been created, this event is now a trigger, that file is accessed, and so on. So it's a very good way to track what's happened in the system. And Windows Defender uses it as a source of information. The problem is that this source of information, which is very interesting, is protected. Of course, if it's interesting, it's protected. So we would like to access it. And we are going to share with you how to disable the security to access it. We need to be with a debugger, WinBag debugger, in kernel debug. It's not a hack, so you are already full power on the machine to do it, but the goal is to track what happens, right? It's not to break the system. So the first things to do is to use this command line in WinBag, wmi trace str dump. It's going to list for you all the logger contexts which are related to ETW provider in the system. And the one which is interesting to know what's happened in the system is Defender API logger. Okay, we select it. And we know by a previous study we did for the Sisyphus project, which was also on the behalf of the BSE, how it works. So internally, it's a WMI logger context structures. So I just short some part of the structure because it's a very big structures. We have the name of the logger. We have also a file where it's contained all the ETL events. And you have the protection, which is stored in a very specific variable, which is a flag. And a flag is just a 4-byte value, integer value for those who like C, which is an hexadecimal value 4000F. And if you check, it's documented. It's very kind at Microsoft. They provide all the information from symbols. You have the persistent, autologger, FS-ready, real time. You have all the information, and you have one flag, one bit in that 4-byte value, which is called security trace, and is set to 1. And all the security matters for it. Let's remove it. So for those who don't want to use directly the full structure, which provide two verbose text, you can directly use DX. I provide also the slide will be shared so that you will get access to this command line. And then what you can do is to transform this flag and remove the 4, because that's the bit equivalent to be removed. So we need literally to remove it. So with the debugger, we have ed, E for edit, D for dword, for integer value in Windows world. You have the address of your ETW context. That stuff is a bit cookie, to be honest. It's just to have something which is independent of the structures and the offset in the structures. In the end, it will provide exactly the offset where the flag value is, but I don't want to compute it every time I'm using this stuff, so I'm using directly the structures from the symbol. And we are just going to keep the last part of that value, removing by definition the bit which was about the security. And ta-dam! The security is gone. So let's take a DLL injection attack just to check how Windows Defender detects step by step. So we have open process, virtual alloc, create process memory, create remote thread, everything classic I would say. Let's go. So we have our own tool for the display, but you can use any ETL or WPP, ETW reader. That will be exactly the same. You have the provider GUID, so which one is providing information? That's the one we have targeted from the beginning. And then you have the name of our process, the command line of our process, relevant arguments for that process, and event ID. And the event ID tells us that in this context, it's an open process action. After open process, we have the allocation of memory with page execute read write, because we have everything over there. We have also the name of the process. Then we have the write into a remote process, so write process memory to write remotely. Then we have the create a thread in the target process. So you have the thread ID and process ID of the target process. Then we have the load the DLL, which is a DLL injection, so it's going to load it, so perfect. And we have from somewhere the name of the DLL. You see the payload? Device, hard volume 2, user. We see that device, hard disk volume 2 is managed by the kernel because that's the way the kernel likes to use file. env, desktop, run command from DLL, and DLL for command execute. Process ID, mesh size, all the information we like. And in the end, we have the detection. Microsoft Defender Antivirus reports unauthorized access to local security system. We have tried to make the injection in lss.exe to be accurate. And you see, platform, HIPAS detection, and so on. So we have all the step-by-step detection of Windows Defender. Sometimes reverse engineering is cool. It's time for conclusion, so that normally everything will be on time. The big picture of how works Smart App Control. Just as a reminder, first we check which kind of image are relevant or not, reminding you that not all images are relevant. And by the way, from documentation of Microsoft, if you are correctly signed, it will be okay. So well. Signature check and get image is still WDAG policy matching, which has a specific policy which makes an external authorization. That's the name from the Windows symbols. The external authorization is actually Cryptcat service, which makes the interface, is going to start, if it's not already done, the smart locker enable. Then it's going to open a file so that Windows Defender can read it remotely from CryptCat service, but that's implementation detail. Then we are going to scan this file in memory, more or less parse it to extract all the information, which are going to be sent via the SpyNet communication to Microsoft. Microsoft provides us a feedback. We pass the information from the feedback, we close the handle, and we take a decision in ci.dll. That's all. What does it mean? Well, you remember that we talked at the beginning of what is SAC and what is not SAC. If I take a picture, the very simplified version of SAC, it's just ci.dll, notify CryptCat service, notify Windows Defender, notifying Microsoft. Now let's consider the case where I take a regular antivirus, for instance, Windows Defender. You see, it's making directly the notification to Windows Defender and it goes to Microsoft. That part, comparing to what he already had before, it's really an open question from my point of view. Why doing that so complex, actually? Because from an antivirus point of view, we have this routine, PS set load image notify routine, which means that a driver supply callback is provided every time an image, DLL executable, is loaded into memory. And if it's not enough, you have mini filter driver, which are able to notify you every time a file is accessed on the disk. So everything was already there from an antivirus point of view. But remember, SAC is not an antivirus. It's not because it behaves like an antivirus. It has almost the same architecture, a bit more complex, but it has the same architecture from a physical point of view of an antivirus. And it blocks applications like antivirus or not, that it is an antivirus. Well, at least in Microsoft logic, I would say. So it has everything to do it. And the best argument to say that Smart App Control is in a way an antivirus that is literally rely on Windows Defender. At the end, in Windows Defender, when the scan analysis really starts, you don't have anymore the name of Smart App Control or Smart Locker and so on. It's just regular notification stuff. And the difference rely, in fact, between antivirus and Smart App Control in the fact that Smart App Control doesn't block non-application to be malicious. It blocks unknown applications that it doesn't trust. Well, Microsoft just replaced the notion of exclusion list, blacklist, in a more direct language, to inclusion list, whitelist. The antivirus made whitelisting. Smart App Control make whitelisting, blacklisting, whitelisting. The cloud analysis mostly relied on executable signatures. As I remember from the documentation, Smart App Control will block unless those files are code signed with a certificate issued by a certificate authority within the trusted root program. Nothing new. That's literally a SAC which doesn't allow applications which are unsigned to be executed, more or less, if they are not trusted by Microsoft. The learning phase, technically speaking, is more or less about to check how many applications with an unknown reputation from Microsoft you use. That's why they call the cloud analysis, intelligent, blah, blah, blah. It's literally like that. But we can have also another point of view on this stuff, because it just, I mean, it's one point of view, but we can try to fit in the shoes of Microsoft for a couple of seconds. The architecture of Smart App Control is unnecessarily complex, but why is unnecessarily complex? Because it relies on WDAC. And maybe we should think that Smart App Control is just an evolvement of WDAC. I mean by that WDAC is supposed to protect your system by applying policy on what kind of application can be executed and which application cannot be executed on your system. But to be able to define the policy to say, that application will be blocked. Not this application, this one, not this one. We have the update, now we need to. It's a huge and complex process to do it, especially in very big organizations. And maybe Microsoft, it's just a guess, might have thought about the fact that we have the feature which is called Cloud Intelligent Reputation, and maybe we can make a mix between all this automatic reputation we already have for application and WDAC, so that WDAC is automatically configured for anyone, so that we don't have to define policy and per application and so on. That could have been the idea, and explaining what Smart App Control rely on WDAC and not directly on the antivirus because it's from the antivirus. But in the end, it's whitelisting, signed, globally shared application execution policy. and it should be done, and it should be seen from an evolution from Windows Vista with code integrity, patchguard for those who prefer, and kernel mode application signing. App Locker in Windows 7, which has disappeared to become something else. We have WDAC in Windows 10. ESG, Internet Secure Graph from Intelligent Secure Graph from Windows 10 also to check the application reputation. And in Windows 11, you have SAC. So you have the evolution, step by step, of this technology. But the main conclusion I would like to share with you is maybe that Smart App Control raises questions. The first one is that the notification is about HTTPS request. Okay, to be able to make it correctly, we will need to have access to the victim's machine to get all the serial number and so on. But nothing prevents us to take the request from a machine and spoofing it or spamming it to another machine, pretending that you are the other machine to deactivate SAC on the other machine by pretending you launch a lot of untrusted applications. That could be an idea to deactivate remotely SAC on another machine. And it's just HTTPS requests coming from everywhere. So it's very hard to control from Microsoft's point of view. But there is another question. As I said, antivirus, if you remember, they have a dedicated driver, a service, and they communicate and so on. But it's a standalone element. If you want to remove an antivirus, right-click and install. You can remove it. But now that SAC is literally embedded on ci.dll, which is a key component feature of Windows, which cannot be removed. Otherwise, Windows will not work. That's raises a question concerning the position of Windows Defender in the system. Because even if Windows Defender is in passive or side-by-side passive mode, Windows Defender can always be notified by SAC. So even if you have another antivirus installed, or even if you say to Windows Defender be in passive mode does nothing, it does something. And that raises the question of the control of the application and the antivirus which are running on your system. And it's not just blocking something, it's also disclosure information to Microsoft. So if you wanted to disable Windows Defender, well, it's not so disable with Smart App Control. And also it shortcuts other antivirus products because it's not the regular path of notification from antivirus to antivirus with different altitude, all of them correctly defined. It's literally another path. So that's raises a question. And there is also no documented possibility until now for third party to interface with Smart App Control. It's always Windows Defender and no one else. So that's raises a real question for our point of view concerning the position of Windows Defender in the system. And on that word, I need to mention some reference, especially the work from N4R1B blogs, which has made a very good analysis of what happens in the kernel for ci.dll for Smart App Control. We reverse it another time by ourselves on our own, just to check that nothing had changed. Some very small detail change, but the logic is always the same. It stopped before Windows Defender. We have continued for Windows Defender. A detailed report of Smart App Control is present on the BSC website. And for those interested by ETW, there is another one also from BSC we have written for them. And all these words, thank you for your attention. It was my pleasure to be with you today. Thank you. Should be okay. We have a little battery issue, but I suppose if there is any question in the room, maybe we can hold one or two. No. Perfect.
All right, now that works. Well, thank you for the talk. Very interesting. Do we have any questions? Right, I come down because the other mic is also empty.
Yeah, thanks for the talk. You mentioned that if you turn SEC off, then you cannot turn back on, right? Yeah. But can you switch between the enforcement mode and the learning mode? I'm not sure about the exact names.
Yeah, when you are in learning mode, evaluation mode, but that's the same stuff in the end. When you are in this context, you can only go to two directions, off or on for it, so active mode if you prefer. But once you are active, you cannot come back to learning mode. It's one way. And the same when you are off, you cannot come back to learning mode, and you cannot come back. You cannot go also to direct active mode. It is off. You cannot say, okay, but just put it on. We don't. The evaluation doesn't matter. So, which is a bit risky, but risky. We are losing control with this kind of application because it's Microsoft which provides us a feedback, yes or no. We have just a toast notification, and that's all. You cannot say, no, I want to change my mind or give me an extra time. No. It's choose, and that's all. And if you want to retry, retest, or change your behavior, it's too late. You need to reinstall your Windows. Nice perspective. That's also the point with SAC. It's more and more everything and nothing software. You use it, you've got everything. You don't use it, you have nothing.
All right, any more questions? Well then, thank the speaker again. Thank you.